Hi guys, welcome to another episode of MrLopezClasses.com. We are going to continue in our diesel engine class. This is the chapter 11, and today we are going to talk about the Keel cooling system. This is a wonderful design. In my opinion, it's an excellent design that every day is more common, because in this system it's not circulation of salt water inside of the boat. This is wonderful. In my opinion, I think that a perfect boat will be a boat with no circulation of salt water inside of the boat. Why? Because the circulation of salt water internally in different equipments inside of the boat accelerate the corrosion of those elements and introduce a lot of extra points of corrosion. If you avoid that the salt water enter in the boat, the corrosion is controlled easy. Yes, in my opinion, in the future, a perfect boat will be a boat with no circulation of salt water inside. Yeah, we need improve the circulation of air, the ventilation of air, and we can eliminate a lot of heat exchangers in different equipments. We are going to refresh quickly. Equipments that use heat exchangers to refrigerate the fluid of that equipment. The generators. The generator is a diesel or gasoline engine connected to a big alternator. Okay, the generators, the main engines, of course. The air conditioning equipment. Yes, in the air conditioning equipment, you have a circulation of salt water around the pipes with freon. We are going to study later in the book of air conditioning that system. Yes, the air conditioning equipments, the marine air conditioning equipments, they have a heat exchanger to decrease the temperature of the refrigerant in the system. Salt water, circulation of salt water. Yes, in the air conditioning equipment we have exactly the same. We have a seacock, we have a strainer, we have raw water pump. We have, for that reason, the life of those equipment depend how is corroded the equipment. Other example of equipment with the circulation of salt water inside of the boat, the water maker. The water maker is other equipment. Yeah, you pass the salt water to the membrane on the water maker, and the membrane separate the solids, and after that the water is converted into fresh water. This is other equipment. Other one, the gyro. The gyro use circulation of salt water in order to keep the fluid of the system at low temperature. Probably those are the most common equipments with internal circulation of salt water in order to reduce the temperature of the equipment. Yeah, but each time that you introduce salt water inside of the boat, circulate and goes out again, you introduce a lot of corrosion. In this system, in the Keel cooling system, you don't need circulation of salt water. You circulate coolant. You circulate coolant through the block and the head, and the coolant goes out, and the coolant is refrigerated outside of the boat. Yes, my friend, this is the secret in this system. In this system, we are going to locate the radiator outside of the boat. This radiator, we are going to locate this radiator. The radiator internally have coolant, but this radiator will be located outside, like this. This is exactly the situation that we have over there. This is the boat, this is the hull of the boat, this is the hull of the boat. And we are going to install internally in the block and the head, we only have circulation of coolant, circulation of coolant, the coolant here, the thermostat is located here, and this is the coolant pump, or freshwater pump, or circulating pump. Yeah, the coolant pump circulate the coolant goes outside The coolant goes outside into the radiator outside of the boat. The radiator is submerged in the salt water, this radiator. The coolant circulates over there and return, and once again circulate internally in the block, and once again goes out. In other words, in the exhaust, in this type of system, the exhaust, I don't need heat exchanger. I don't need heat exchanger because my radiator is located outside of the boat. Yeah, the refrigeration of the coolant is outside of the boat with the salt water. The salt water is located outside. You have two pieces of zinc located here, and those triangles, those pieces of zinc in each corner, are used to help to improve the flow of the salt water and to avoid that debris and other particles be located in the middle, in between the fins of the radiator. We are going to talk right now about that. This is the system. This is another picture. If you see this, the coolant goes out, circulate through the radiator with coolant, and return here and enter again into the thermostat housing and circulate and circulate and circulate. Yes, my friend, this is a wonderful design. No heat exchanger, of course, no raw water pump, no strainer, and in my opinion, the most important, the exhaust is dry, no wet exhaust, no humidity, no salt water on the exhaust. This is wonderful for different reasons. When you check outside through the exhaust pipe, you only have gases, smoke, gases, and you don't have salt water coming out. Why this is excellent for the environment? Suppose that the engine is using an improperly fuel, a fuel with too much level of sulfur and too much level of nitrous and phosphorus. Suppose that the fuel is not the appropriate fuel. Okay, that engine produces too much nitrous oxide, sulfur oxide, phosphorus oxide. What happens when those oxides are mixed with the salt water? Produce sulfuric acid, nitric acid, carbonic acid, all of those lethal acids. This is not good for the environment. In this design, you don't have that inconvenience because you don't have humidity, you don't have water in the exhaust pipe mixing with the oxides. You reduce the contamination on the ocean. You reduce the introduction of acids into the ocean. This is wonderful. This is excellent for the environment. And is good for the technician because the exhaust is dry, and you can see easily if the color of the smoke is white or is blue or is gray. Depending on the color of the smoke, you remember, we are going to identify what happened in the engine. The mixture is lean, the mixture is rich, too much fuel, too much oil. Yeah, we are going to check that situation. Yes, my friend, this system is excellent. This system, in my opinion, is the best because you eliminate the circulation inside of the boat, the circulation of salt water. This is, in my opinion, the worst part of the design of the boat, the circulation of salt water internally in the boat. We are going to study in details that situation in my book of corrosion. This is a wonderful book. You found that book in my webpage, and you can buy the book and the videos also. Check my webpage, mrlopezclasses.com. Okay, my friend. Yes. Now we are going to talk about that system. What is the secret in that system? The secret is this radiator, the radiator located outside. Okay, we are going to check what happened in that system. This is another good picture about this system. This closed circuit cooling system eliminates the need for inboard heat exchanger, of course, and no raw water pumps and no strainers. And also the maintenance is too simple. And internally, if you check the engine room is clean, no corrosion. This is in my opinion, the most important part of this system. This radiator is located outside. This radiator is located outside in contact with the salt water. Okay, and you don't need raw water pump because you don't need circulate raw water pump internally. But you need the coolant pump, the fresh water pump. You need this pump, no? The coolant pump. The coolant pump circulate the coolant internally in the block and send the coolant outside to the radiator. In some cases, it's necessary because the amount of coolant is more, and you have the coolant outside of the boat. In some cases, you need another pump connected in series with the actual coolant pump, and you need other electrical pump in order to help with the circulation of coolant. Yeah, depend of the distance. Normally, the manufacturer of those Keel system, of those Keel radiators, they recommend install the pump, and they supply with the external radiator. They supply the gaskets and they supply the extra pump. And I recommend, this is an electric pump, DC pump, 12 volts or 24, depending on the voltage of the engine, and you connect that pump connected directly into the ignition switch in the ignition position. In other words, when the engine is running, that pump, the coolant pump is running, is circulating the coolant internally in the engine and outside into the radiator, and once again engine radiator. Yeah. In other words, you have two pumps connected in series, and in order to improve the flow of coolant. Okay, my friend, this is the situation, and this is a better picture about the Keel cooling system. If you see the piece of zinc at the end, this piece of zinc is used to protect this copper alloy. Right now we are going to talk about this copper alloy, and a special alloy. Wonderful. It's an alloy that is practically zero corrosion, and look, this is the through hole that we are going to do in the hull in order to install this element. You are expert doing through holes. You remember in our course of electronics, we practice doing the through hole when we install the transducers. We practice with the hole and with the tools recommended, and we are going to practice in other course later in the course of auxiliary system. I'm going to explain again the procedure to do the holes, the recommendation when you make a hole in the bottom of the boat, and the procedure to install appropriated any type of through hole or transducer or a killer cooling system. Okay, this is the system, and yeah, the best part of this is the elimination of the heat exchanger and raw water pump and strainer. It's less maintenance and less points of corrosion. Yeah, I love this picture. In this picture, you have an extra couple of valves. One valve here, and other valve over there. And those valves are excellent, and you have extra valves here. Those valves are excellent in order to do the service on the Keel cooling system. We are going to check. We are going to analyze in this picture the possibilities for problems with the cooling problems in this system. Okay. I have a lot of questions for you, and I want that you navigate with me through the system. In this system, I only have circulation of coolant. The coolant starts in this point, and the coolant continue over there. The coolant goes outside, circulate through the radiator. This is the coolant, and the coolant return over there, and enter here the thermostat housing, and once again continue, and return over there. This is basically the path of the coolant. Okay, I don't have circulation of salt water. Excellent. And look at this. This is the expansion tank, the metallic expansion tank, and the expansion tank, you remember, is connected with the coolant reservoir. Okay, I open the radiator cap the radiator cap here in the expansion tank or here, and I found it that the color of the coolant is brown. This is because the coolant is mixed with salt water. This is the typical indication that the coolant, and also when I removed the radiator cap, I found a lot of calcium, like a salt. This is an indication that the coolant is mixed with salt water. What happened in this system? I don't have circulation of salt water. Why the coolant is mixed with salt water? My friend, remember that the radiator is located outside of the boat, submerged into the salt water. What happened if the pipes, the copper pipes are cracked? The salt water penetrates into the coolant. For that reason, you have salt water in the reservoir or in the expansion tank. That's not good. This is a worse scenario. All right, you need to flush the system, and probably normally the problem is outside. Normally the crack is outside. Normally the crack is here in this element. It's outside. It's located here. In that case, what is the procedure? The procedure is put the boat out of the water. You need to go to the marina and leave the boat and put the boat outside of the water and check the killer, the radiator, and remove the radiator and send that radiator to the machine shop in order to pressurize the radiator and verify where is crack, that element. Yes, my friend, normally it's a crack over there, or in some cases it's a problem here on the gaskets, of this element, those gaskets. Those rubber neoprene gaskets are damaged, or any part of the cooler is cracked. You need to send the cooler to the machine shop. They pressurize the system and they identify where is the crack and they repair. Normally it is easy to repair those elements. Yes, this is possible that you have a salt water mixed with the coolant. It's because externally you have a small crack on the radiator, or the gaskets located here in between the hull and the radiator are broken or deteriorated, and you have a small migration of salt water into the coolant or coolant into the salt water, both of them. Yes, if you need added frequently coolant into the reservoir in this system, it's because you have a leak of coolant. Oh, but my bilge is clean. Okay, the leak is not inside of the boat. Probably the leak is outside. And you need to verify where is the leak, and you need to solve that leak. Other typical procedure is identify when the engine is hot. Oh, the engine is running, and after 10 minutes of operation, the needle on the pressure gauge goes to the red area. Yeah, you need follow the same procedure that you follow in the previous system, in the heat exchanger system, when you analyze the coolant side of the system. Okay, we are going to do exactly the same procedure. We are going to start on the reservoir. We are going to verify the color of the coolant, and after that we are going to enter into the expansion tank. We are going to verify the cap. We are going to verify if the cap closed properly, if I don't have calcium on the radiator cap. And after that we are going to check the thermostat. We are going to remove the thermostat carefully, and we are going to introduce the thermostat in water and verify if the thermostat open and closed properly. And after that we are going to check the coolant pump or circulating pump. No lateral play, no leaks in the bottom hull. Okay, the coolant pump is damaged. I replace the coolant pump, and also I am going to verify if the pulley on the coolant is good, with no play, with no indication that the shaft is in good condition. Okay, this is basically the procedure to check the coolant side. In this system, it's very common added a couple of filters. Those filters are very important because those filters are water separators. Remember that the density of the coolant is higher than the density of the water. If you have a coolant mixed with water, the water goes in the bottom and the coolant on top. and it's easy to identify if you have those water separators, if you have a concentration of water, and immediately you need to stop the engine and check the radiator externally, probably remove the radiator, send to the machine shop, and after that putting back the radiator. Yeah, the strainers are very, very important in order to verify the migration of salt water into the coolant. And you have another filter here. This is for bypass. This is when we need to isolate the system and do the service on the external radiator, on the heat exchanger. Other important function of the strainers is verify the color of the coolant. It's important that you keep clear those filters in order to check if the coolant is moving, if the coolant doesn't have bubbles. Remember, the enemy of the majority of the fluids is the bubbles, the air, and identify that the salt water is not mixed with the coolant. This is other point of inspection that you need added in your list when you are inside of the engine room. Remember, you have a lot of inspection points. In electricity, you need to verify the level of the electrolyte in the batteries. You need to verify the level of charge on the batteries. You need to verify if the battery chargers are working. You need to verify if the ventilation of the battery charger is properly. You need to verify if the voltmeter and ammeter indicate the appropriate voltage and amps, and you need to identify if the batteries are not hot, or this is if the batteries are too hot and you have a electrolyte going out, it's because you have overcharging. And you need to verify the raw water pump, the seawater strainer, if the strainer is clean, if no bubbles on the strainer. You need to verify also the fuel filters, the water separator fuel filter. I'm going to explain later in the next chapter. This is a wonderful chapter dedicated to the fuel system. And now you have another water separator filters for the coolant if you have a killer system with the radiator externally. You need to identify if the coolant is in good condition, is pretty clean, and no water in the bottom of those filters. Okay, this is basically the system. We are going to check the elements that are involved in this design. You have a couple of valves in order to isolate the external radiator. Additionally, you have other two valves here and here in order to bypass the system for service, and you have strainers in order to separate strainers with water separators in order to separate the water and the coolant. This is an ABYC question. What is the function of those strainers? And other one ABYC question is the function of the shut-off valves. The function of those shut-off valves, this and this, are for service, for purposes of service, in order to isolate the engine from the external radiator. Yes, my friend, this is the system, the cooling, killer cooling system. And now we are going to check a little about the materials and about the position of the radiator. Look at this. This is when you buy, for example, can I convert my typical boat with a traditional heat exchanger system into Keel system? Yes. The only that you need is identify where should be located the new radiator outside of the boat. Identify if you have a special area or a special pocket in the hull where you can install those radiators, or if you need mounted externally with those triangles. Those triangles of zinc help the flow of the water. They help the flow of the water and improve the performance of the radiator, and verify where should be located the two holes in order to install the external killer. Okay, and this is one position. Other one is in some boats. Originally, the boat have the pocket where the radiator should be located. Yeah, there are boats that originally they come with those radiators. For example, this system install the radiator in this area, in this triangle. You remember the shaft of the propeller. The propeller is here, and this is the hull. You remember this triangle. some people install the Keel radiator over there. In my opinion, this is not good, because in this area you have a big bubble of air, because the flow of the water produce in the turbulence a big bubble of air. That area, in my opinion, is not good, because depending on the speed of the boat, a big bubble of air is produced for a long period of time, and you can produce overheat on the engine. This is a no good area. Some boats, they have the radiator located on the side of the hull, because originally have the pockets to install the radiators, or they install externally those radiators. I don't recommend, if the boat doesn't have the pockets originally to introduce the radiators, I don't recommend install those elements on the side with no pockets, because you can damage those radiators when you leave the boat in the marina with the travel lifts. Probably with the straps of the travel lift you can damage those radiators. Be careful with that. This is not recommended. Okay, those are the gaskets, important gaskets that you need to replace each time that you remove the external radiator for service. You need to replace those gaskets. Those gaskets are in a special material. It's a special neoprene, and the manufacturer, in this particular case Duracooler, they supply to you those gaskets. Those gaskets are designed to work in permanent contact with salt water and coolant, and the material is a special material. And also the torque applied on those nuts should be exactly the torque recommended by the manufacturer of those radiators. If you apply extra torque, you deformate too much the gaskets, and 100% sure that you have leaks. For that reason, you need to be careful when you replace the gaskets, and you need to be careful when you install a new radiator with the gaskets, the bolts, the nuts, and the torque. Okay, now we are going to check the material. The material of those external radiators is once again a copper nickel alloy. Copper nickel alloy 5000 series. This 5000 is 15106 is series 5000. A lot of alloys, series 5000s, are copper nickel. This is an expensive alloy with high content of nickel. High content of nickel. For that reason, in the next episode, we are going to study the refrigerants, the coolant, and we are going to analyze the sample of coolant. When you send to the laboratory the coolant to analyze the coolant, we are going to check what happened with the concentration of different metals and minerals in order to identify where should be located the problem of overheating that I have in my engine actually. Yes, those alloys are fabricated in copper nickel, and those alloys are practically zero corrosion. Let me give to you one small introduction to the book of corrosion in the future. You remember in ferrous alloys, what is the alloy that is less corrosive with respect to other alloys? Yes, it's stainless steel. And you remember how much should be the concentration of chromium in the stainless steel in order to eliminate the magnetic properties and the corrosive properties? Yes, it's in between 10% and 18% maximum, no? Of chromium. In other words, the chromium in a ferrous alloy eliminate the corrosive properties of the alloy, of the ferrous alloy. This is in ferrous alloy. In non-ferrous alloys based not on iron, in other type of metal, alloys of aluminum, alloys of copper, alloys of magnesium, those non-ferrous alloys, the element that eliminate the corrosive properties of those alloys is the nickel. For that reason, in this particular case, I have bronze, it's a copper alloy, with nickel. Yeah, this alloy, this is a naval bronze, with a high content of copper, of course, 90%, and 10% of nickel. It's a high content of nickel. Yeah, nickel is the element is the metal in the non-ferrous alloy used to inhibit the corrosive properties. And chromium is in ferrous alloy, the metal used in the alloy to avoid the corrosive properties. Don't forget, we are going to study that situation later in our class of corrosion. A wonderful class, a wonderful book with great videos. Okay, my friends, this is the property of this material. And yes, and the welding in between those pipes is with silver brass. Silver brass. Yeah. And there are other, the copper nickel units are welded with silver brass. This is for copper nickel. And there are all external radiators like this in aluminum, in a special alloy of aluminum. And of course, the welding in those alloys should be with pure aluminum. Yes, there are external radiators for Keel cooling system in aluminum, and external radiator for Keel cooling system fabricated in copper nickel alloys. Okay, very important. Okay, questions and answers related with the Keel cooling system. Some people say no, the Keel cooling system is not recommended for boats, for high-speed boats, and this is not true. Keel cooler are currently used on high-speed patrol boats because basically they don't have a resistance, they don't produce drag. This is not true. The Keel cooler system can be used in high-speed boats and low-speed boats, no problem. The Keel cooler system must be mounted in a pocket. Yes, any type of cooler may be mounted in a recess or just externally on the side or on the bottom of the boat, like I explained before. It's not an inconvenience. Those systems require too much through holes? No. Let me explain something about that. Let me explain something about that situation. In some boats like this one, let me explain. Okay, in this one, if you check this design, the design that you have on the screen right now, in this particular design, you only need to make one hole. And inside of the hole, you have two pipes. One pipe for input and the other pipe for output. Or input and output and return. No? You can order the external radiator with both ends concentrated in one hole, or with two holes separated, and one is for input and other one is for output. In this particular case, you need to make two holes, one hole per each through hole. Depend of your boat, depend of the design, and depend of the space that you have in the engine room, you can take the decision of two holes. What is the advantage of the external radiator with two holes? Is that the support is better. The other one with only one hole, if the radiator is too long, is not good because produce too much torque in this hole. Of course, there are brackets in order to support the radiator properly, but both of them are efficient. Depend of the conditions in your boat, the internal conditions in your boat. With one hole or two holes. Don't forget, the very important is the gasket. The gasket is critical. The gasket should be replaced always. And normally, in my experience, the majority of the problem with that system is with the gasket. Let me tell to you a history. Some years ago, I make a mistake because I was working in a marina and my job was replace or remove the external radiator in order to send the radiator to the machine shop for the testing procedure. And when I entered in the boat, I only found one valve to close the flow of coolant, and I closed the valve and I checked and only found one valve. And when I remove externally the radiator, the radiator have two holes. Of course, when I lose the bolts, immediately I have a lot of coolant going out in the ground of the marina, and it's because I never identify where was located the second valve. You need to be careful with that. You need to verify, be 100% sure that you close properly the valves. In other case, I make a mistake because I turned the handle of the valve, but externally the handle was damaged. The handle moved, but the ball internally never moved, and the valve stayed open. In that case, I spill a lot of coolant again. Be careful with that. Be careful with the valves. Be 100% sure that the valves close properly. What valves? I am talking about exactly these valves. About this valve and this valve. You need to close those valves properly before you remove the external radiator. Be careful with that, because in one situation I forget one valve. In the second situation I close the valve, but internally the valve never closed. Be careful with those valves. I love that system because that system eliminates the flow of salt water internally in the boat, and in this system it's easy to troubleshoot with temperature. What is the inconvenience of this system? For example, at north in Alaska, during the winter, yeah, probably the radiator externally in contact with the ice clogged the system, but for that reason there are inhibitors in order to reduce the freezing point of the coolant. Right now, in the next episode, I am going to explain those inhibitors. There are inhibitors to increase the boiling point of the coolant, and there are other ones, additives, in order to reduce the freezing point and avoid that the coolant be froze. This is a big problem, but yes, those inconveniences can be solved with additives in the coolant in order to avoid that situation. But yes, that this system is commonly used every day, more and more, in areas like Caribbean. No, at north, the people prefer those systems in the Caribbean. In the Caribbean is wonderful. Okay, during the summer, the heat transfer is, the range of change of temperature is less because the temperature of the seawater is high, but that system is good with additives. You can solve that situation because you can increase the boiling point more and more depending on the coolant used and the additives used on the coolant. Right now, in the next episode, I am going to explain that situation. Don't forget, the other name of this system is a dry system because the smoke going out is dry with no salt water. This is dry. The diagnosis is easy, and internally you don't need heat exchanger. You don't need heat exchanger. You don't need raw water pump. You don't need a strainer. Thank you.